And hello, this is just a Jolt here, but it's Mr. Jolt today because we're going to be doing some GCSE Maths. It's just for anybody who's stuck at home, who does not really want to be doing the maths they've been sent home for school, but who wants to be doing something productive. So I thought I'd come and I've tried to make it a little bit more, well, it's Jolt doing it, so of course it's going to be more entertaining. So here's what we're going to be doing. We're going to be using the website that I've been building. It's this one right here. We're going to go to GCSE Maths. And we're going to go ahead straight away, and we're going to go and have an algebra question. Let's go to, rather than doing a random one, let's start off with something really, really basic. We're going to go through a few of these. Now, first things first, this here is quite basic. So what we're going to do is we're going to stick that up on the board there. So we've got 24 divided by 3. All right, 24 divided by 3. Now, what's difficult about that? Obviously, the answer to 24 divided by 3 is 8, but if you have a look there, just back here, what we're actually dealing with is positive and negative numbers. All right, positive and negative numbers. And so what I want to do is look at positive and negative numbers using this example right here, randomly generated by the website, which I built, which I'm proud of. Okay, so now moving on. If I've still got audio, I want to make sure that you're still hearing me okay, because if you're not, that would really stink. There we go. Look at that. I cannot believe. There we go. Let's just have a look over here. There we are. There we go. Okay, so 24 divided by 3. Obviously, well, what if it was minus 24 divided by 3? Or 24 divided by minus 3? How would that affect the answer? Well, the rule for positive and negative numbers is very, very simple. Basically, if you have a negative minus 24 divided by 3, a negative divided by a positive is going to be a negative. So that's going to mean that the answer is minus 8. If you have 24 divided by minus 3, the answer again is going to be minus 8. If, however, something like this happens, and you have minus 24 divided by minus 3, well, these negatives kind of cancel each other out, because you've got a negative divided by a negative, and so the answer ends up being positive. So the answer to this is going to end up being 8. Now, if I go back to my website right here, I can actually check that answer, which is phenomenal. Let's go and check that. And the answer there is, of course, 8 right there. So let's have another one. Let's have another one. Now we've got 6 times minus 7. Well, what we're going to do in this case is very, very simply, we're going to go, let's see what we've got again. 6 times minus 7. And the first thing we're going to do is just plain write the answer to 6 times 7. So 6 times 7 obviously is 42. But because we've got a negative here, you can see here the pattern. Because there's one negative, the answer is also going to be negative. So the answer should be minus 42, which is the opposite to the meaning of life. Let's go and take a look at that and see if that's correct. And the answer, of course, minus 42. Let's have a look at another one. 12 divided by 3, that's quite easy. That's going to be 4, obviously. Let's see if we can find one with negatives. That's more interesting. There we go. So we've got minus 6 times minus 8. But minus 6 times minus 8. Now, do you remember what we said before? In this case, we've got a negative times a negative. So we're going to start off just by doing the math. 6 times 8 is, what's 6 times 8? Well, 5 times 8 is 40, because it's half of 8. Let's stick a 0 on the end. 5 times 8 is 40. And 6 is going to be then 48. And minus times minus is going to be a positive. Minus times minus is a positive. So let's just check the answer's correct there. And there we go. The answer's 48. What I'm going to do now is I'm going to press this again and give you guys a chance. Just have a go at whatever comes next. So we've got 4 divided by 2. Take a moment on that. Shouldn't take you very long. There we go. Minus 4 divided by minus 2. Let's do this together. See what answer you got. Minus 4 divided by minus 2. Well, 4 divided by 2 is 2. They cancel out, so the answer is going to be positive. So the answer is 2. Why don't we move on to something a little bit more challenging, because that is actually quite easy. Let's rub the board in true teacher style. I always used to do it with my hand when I was in a mainstream classroom, actually, but I am going to use a tissue today, not because I'm afraid of coronavirus, but just because. There we go. Let's get rid of all this. Doopy 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 doopa. And we are going to move on to the next question in the algebra section. Now, it is dealing with positive and negative numbers, multiplying and stuff. Is that algebra? Well, yes, because eventually you are going to get things like x. So what we're going to do is go back to this website. Let's go back here. You've got to close this page. And now let's have a look at multiplying letters. Now, in this case, we're not going to be using positive and negative numbers, but we need to just know that for what we're going to be doing. But here's multiplying letters. So here we have got m times j times m times m. All right, so we've got an interesting situation here. What happens in this case? Well, if these were numbers, then it would be quite easy. We would just kind of multiply them together. But let's pretend for a second that they are numbers, and let's see what would happen. Let's pretend that our j is a, let's say it's a 4, and let's pretend that m is 2, and let's see what would go on. So the first thing I'm going to do is collect all these together to make it easier to see exactly what's happening. So let's have 4 times 2 times 2 times 2. There's another 2 there. There we go. There's another 2. Yeah, because we can do maths. So the 4 we can just kind of leave by itself. But what I'm going to do is focus on these 3 right here that are all together. Now, some of you guys might be familiar with this idea of something being squared, something to the power of something else. So 2 times 2 is obviously 4, but we can also write that 2 times 2 as 2 squared. So 2 times 2 is 2 power of 2 because there are 2 2's. Now, 2 times 2 times 2, well, if you're timesing something by itself 3 times, then you wouldn't have squared anymore. You would in fact have cubed. That equals 2 times 2 times 2 is 2 cubed. Basically, to work out this value here, to work out the indices, you just look at the number of times that the number times is by itself. Let's say you'd have, let's say x is a really bad number to use for this. Let's say you had y times y times y times y. Well, that would equal 1, 2, 3, 4. You'd have y to the power of 4. All right, so that's what you would have. So in this case, what you'd actually have, this is equal to 2 to the power of 3. So we can actually just write 4 times 2 to the power of 3. And then if we really wanted to, we could go and work out exactly what the answer to this is. But we were just using this as an example to work out this up here. So the first thing that we're going to do, focusing on this up here, is we're going to collect the like terms so that they're all kind of next to each other to make our lives a little bit easier. So let's go ahead and collect those like terms then. So we've got j times m times m times m. All right, and now we've got the same situation before where we have the j all by itself, and then we have m times m times m. Well, times by itself 3 times. What we're going to end up with is j times m to the power of 3. In algebra, what we can also do is we can drop this, because if 2 numbers are next to each other, then they're multiplying, and that's just the way we write things in algebra to keep things simple. Otherwise, you'd end up with lots of these all over the place, and that makes it really difficult when you start dealing with things like this, where you have x plus y, and you get this confused with that, and so it's just easier to just drop it. So what we can actually write is j m cubed. And I'm going to ask a quick question here. Is this the only way to write this answer? Well, yes and no. No, actually. Altogether, because there's nothing stopping you from flipping these 2 around. It's still exactly the same thing. So just to show you what I mean there, 2 times 4 is 8. Well, what's the answer to 4 times 2? Well, that's kind of also 8. So the order that you put these in really is kind of irrelevant. So if I wanted to, I could also write m squared times j, and that would be fine as well. So now let's go back to the website right here. Let's see if that's the correct answer. And what we get, in fact, is m cubed times j. Let's generate another one. There we go. Let's have another one of these. And now we've got a slightly different one here. I'm going to write that up on the board. Right out, make some space here. There's probably an easier way I can do this using more technology, but let's just do it this way for now, because we're just kind of doing this very quickly for anyone who's bored at home and wants to see Just a Jolt doing some maths. So m times v times m, that's up on the board now, and I'm back right here, back once again with the Renegade Master. Leave a like if you recognise that tune. All right, q times m times v times m. Well, the first thing we're going to do is we're going to put terms together which are the same. So let's have q times v times m times m. And obviously we can't do anything about these, but we can do something about these. These will in fact become m squared, so we can get rid of them, and that's now m squared. So what we end up with is q times v times m squared. What did we say about these multiplication symbols? Well, they get kind of awkward. If we can avoid you having them together, then we will. We can't just leave them out if we're just dealing with integers, with numbers, but we can do if we're dealing with letters like this. So in fact, we end up with q VM to the power of 2 QVM squared. Is there another way we could write this? If we wanted to, we could write QM squared V. We could also write VQM squared. There is a whole number of different ways we could write this. There are 9 different ways, I believe, in fact. Maybe 6. I don't know. I haven't got a clue. Anyway, let's go back and check our answer. Did we get the correct answer? M squared V, that's this one that we wrote, but all of those are the same. It's all the same thing. There's no real difference. Let's do one more of these then. Let's do one more of these. This is what we've got generated here. We've got, use this space here, T times C times C. And this is an interesting one because what we were talking about earlier with this whole kind of number squared thing, what we end up with here is T times T, of course, is T squared, and then C times C is C squared. Let's go and check our answer using the helpful website here. And we find that, well, you know, they've kind of reversed it for some reason. When I wrote this, you know, it does quirky things to the numbers. It has reversed it, but it's not a problem. It's still the same answer, so that is still correct. We'll have a go at a couple more of these, and then we'll move on to the next thing on the website. If you're joining us here, this is Just a Jolt teaching maths because I want to do my part to help make it easier for you guys to be at home learning and not getting bored stiff out of your brains. And I kind of think that me doing the maths might make life a little bit easier. It might not. It might not. Who am I to be teaching you maths? Well, I'm actually a qualified physics with maths teacher, mainstream experience and all that kind of jazz. But anyway, let's have a look at our next one. So we've got V times I times N times N. So let's have V times I times N times N. And let's just have a quick look here. So we can have a look in the live tab. There's like one person watching, nobody commenting yet, but that's okay. That's okay. I'm going to soldier on anyhow. Right, so we've got this. Obviously, this one's going to be easy too. We've got this situation here, which is going to make an n squared. So we've got V I N squared, Vin squared. That's what you get if you get lots of Vin Diesels together. Let's just check our answer here, make sure it's getting right. There we go. And we've in fact got Vin squared, exactly what it said on here. Let's do one more. C times M times M times C. If you ever get to do exams, you might get a situation like this where they try to mess you up and you get answers like, I don't know, you might get 2cm or something, which actually, you know, you could do that as well. But in this case, what I actually want to see, I mean, actually 2cm wouldn't be right at all. Would it? I don't know. So you got C squared M squared, and you got C squared M squared. Let's check the answer here. And you got M squared C squared. Let's have one more of these. We've got S times G times G times G times G times G. And the answer should be SG cubed at this point, because 1, 2, 3, there's 3 of those, which means we're cubing. In fact, let's just check our answer. And that's exactly the same answer as I got, is it? Yes, it is, which is fantastic. Let's go back again. We can just close this window up here and have a look at the next thing. We've got this thing called collecting like terms now. So I've just so you can see what I've done. I'm now clicking on collecting like terms right here. And this is a little bit more interesting. There's a little bit more going on here. A little bit more going on. So let's wipe off what we've got. Clear this board. Very, very little board. Maybe I should get a bigger board. We're going to need a bigger board. There we go. Let's have a go at this. And now we've got C, and we're no longer timesing now. No longer timesing. We've got C plus C plus 7 plus C plus, I'm running out of space here, 7 plus C, oh, good heavens above. I'm going to start that again. So we got C plus 7 plus C plus, am I even writing this legibly? Yeah, kind of. 7 plus C plus 7. And then we've got an interesting thing here at this last term. It actually says NC plus NC. Now, just now we were multiplying letters together. Now we're doing things slightly differently. We're no longer multiplying these letters together. No longer multiplying. No. We're now doing something a little bit different. So we're collecting like terms. What exactly does that mean? Well, basically, this is pretty messy. And so what we want to do is collect everything together so that we can see what we've actually got. It's like if you've got a whole bunch of different types of Nerf darts, and you're like, and you really want to know, kind of, you want to organise your collection a bit. You want to see what's going on. If you can see behind me here, there are just Nerf guns absolutely everywhere. But you'll notice there that I've collected like Nerf guns together back there. I've got all the vintage ones over here, and I've got all the other ones that, you know, I've got sniper rifles back there somewhere. And so I've collected all of these like terms together. And so I want to do the same with this. So the first thing I'm going to do is rewrite this, and I'm going to put everything together, which can go together. So I've got C plus C plus C plus C. That goes by itself because it's actually different to those C's. It's NC, it's different. It's a little bit like if you've got, like, I don't know, you've got a, I can't even think of an example, but you get the idea. Right, plus 7 plus 7 plus 7 plus NC. So there we go. Look at that. I've collected all the like terms together. Isn't that fantastic? Well, yes, in that it makes it easier to see. It makes it easier to see what's going on, but know that it's still rather messy. So let's keep on going further with this whole collecting like terms jazz, shall we? Yes, let's do this thing. So how many C's have we got? 1, 2, 3, 4. We've got 4 C's here. That means 4 to the power of 4, does it not? Well, no, it doesn't. Because C plus C is different to C minus C. It's very different. Let me just illustrate that to you right now. So 2 times 2 times 2 equals 2 to the power of 3, which is 2 times 2 is 4 times 2 is 8. Whereas 2 plus 2 plus 2, well, 2, 4, 6, that's just kind of, I'm going to leave a little space there. That's actually, the answer to that is obviously 6, because we're not timesing. But how would you represent this? Well, 2 plus 2 plus 2, let's pretend that these are letters for a second, that you can't multiply together. Let's pretend that for just a moment. So let's have n plus n plus n. Well, this is now difficult. How do you represent this? It's not going to be n cubed, is it? So what's it going to be? What could we call this? Well, n plus n plus, well, there's 3 n's, isn't there? There's 3 n's. We can't multiply them, so I don't know. What about this? Can we do that? And yes, we can. That's exactly what we can do in this case, where we are adding the same number together, like numbers, like letters. We can do that. So C plus C plus C plus C is actually going to be 4C, not C4. If I say that word, there would be people all over me right now from the CIA or whatever. 4C plus. Well, what, are we going to write 37 here? Well, no, we're not, because we know what 7 is. We know what value 7 is. And 7 plus 7 plus 7 is 21. And NC is all by itself, so plus NC. And so that's my answer. Let's see how that compares with what's on my delightful website. And we've got 4C plus, oopsie daisy, look at that. 4C plus NC plus 21. Does it really matter that it's in a different order? Not really. Doesn't really matter that much. At all, actually. Let's have another new question. So let's have a little look here. Another question. We've now got C plus 7. This is exactly the same question, just it's not even the same question. I didn't even change it. There we go. That's more like it. That's more like it. That's what we want. That's what we want. So I'm going to give you a chance to write that down. If you want to write that down, I'm going to go ahead and write that down on the board whilst you're writing it down on a piece of paper so you can follow me. Always follow what I'm doing. Never just sit there doing nothing. Always be doing something. So you got 3 plus V plus VT plus 3 plus VT plus V plus, that is V, yeah, plus VT plus VT. Now, a word of caution here. You'll notice that my T's and my T's and my pluses look very, very similar. So just be aware of that. That's one of the tough things in doing this. One of the difficult things is making sure that you keep things separated. Notice there's one person watching here. It could well just be me watching myself, which is fine too because I love the sound of my own voice. Right, so let's now have, so what's the first thing we've got to do here? Well, this is quite messy. So the first thing we're going to do is we're going to put all of these together the same as we have up here, shall we? So 3 is the first thing. So let's have 3 plus 3. They are only 3s. Yep, only 2 3s. Plus V plus V. We've only got 2 V's there, so that's all we've got to put together there. Plus VT plus VT plus VT plus VT. Have we collected the like terms? Kind of, yes, but we've still got to simplify them and squash them together and collect them more betterly. So let's go ahead and do that. Let's collect these. 3 plus 3. Well, we're not going to write 2, 3, are we? Because we kind of know what 3 is. So let's just write that as 6. And now we've got our 2 V's. Is that V squared? Well, no, it's not V squared. We already know that it's not V squared. Hello there, Daniel Dallas. There we go. A-level GCSE Maths by Daniel Dallas. It is fantastic for you to be the second person have you doing this as well. I have to take a look at your channel. Basically, I am a qualified physics with maths teacher, and I'm doing this just for people who may be stuck at home right now. I'm actually tutoring from home as well, which is incredibly useful. Great to have you here with us right now. And now we've got V plus V, which is going to be our 2V. Remember the difference here between multiplying by 2 and adding 2 things together. We end up with that 2V thing going on. And then finally, how many VTs do we have? Well, we've got VT plus VT plus VT plus VT, which means we are in fact going to have 4 VT. Now let's go back to my delightful, wonderful website and just see how that looks. Let's see if that's the same answer as we get here. So we've got 2V plus 4VT plus 6. Does it matter that it's in the other order, that it's in a different order than what I've written it? Well, actually, no, it doesn't. Actually, no, it really doesn't matter at all in the slightest. So that is the correct answer as far as I'm concerned. Let's have another question. We'll just do one more of these, then we'll maybe move on to something else before we finish up. So I'm going to give you guys a chance to write this down, while in the meantime, I write this down on the board. So if you just scribble down what's popped up on the screen there in front of you, scribble it down. There's nothing stopping you either after this is all finished from going and practicing any of these that you want to practice as much as you want. Let's have Q plus EQ plus EQ plus Q plus Q plus Q plus 1 plus E. Now, I programmed this to be just kind of slightly, nuts, a little bit crazy, so that's why it sort of comes up the way it does. There is nothing at all wrong with getting a bit of extra practice in this sort of way with stuff that's a little bit weird. This, by the way, is a Q. It's a Q. That's what it is. It's a Q. So let's have Q plus EQ plus EQ. What's the first thing we need to do? Well, I've rubbed everything off the top now, so you're going to have to kind of remember. So the first thing we need to do is kind of collect these together. Is there a reason? Is there a reason why? Is there a reason why we couldn't just straight away, rather than kind of writing this all out again in the right order, is there a reason why we couldn't just go ahead straight away, count them up and write them down? Well, no, there's not. Now that we've got the hang of doing this, there is no reason at all. Q plus Q plus Q plus Q. Well, that looks like 4Q to me. Let's have 4Q plus EQ plus EQ. That's 2EQ plus 1. Why don't we just wait, and why don't we just add that 1 in at the end to make it tidier? Let's put numbers in at the end to make it tidier, shall we? Plus E. There we go. And let's see if that's the same answer that my website generated for us. Let's take a little look, shall we? Oh, we've got E plus 4Q plus 2EQ plus 1. Everything's there that needs to be there. It's close enough. Fantastic. So anyway, let's have a little look down at the chat again. Oh, Daniel Dallas, A-level GCSE Maths by Daniel Dallas. Fantastic to have you with me. I am going to check out your channel and have a little look. I'll go and do that after I've done this. There we go. Yes, A-level GCSE Maths by Daniel Dallas. I will be assessed using my current grades. My situation is ever so slightly different. The reason being because I'm tutoring students who are deaf and autistic at the moment from home. And for that reason, it's going to be slightly different to me. They're going to be sitting exams next year anyway. This is for the benefit of anyone who is in the current year 10. Anybody in the current year 10 who is going to be hopefully taking their GCSE exams next year. You are really from digital marketing. That is cute. I am not really from digital marketing. And so this channel right here that I do. So if you go and check out my main channel, which is Just a Jolt. So Just a Jolt. I am actually a Nerf YouTuber as well, and the digital marketing stuff is because I actually run Nerf parties as well. So I did run Nerf parties when it wasn't all this stuff, and so I got quite good at the whole digital marketing thing. And so basically, I started up this channel, but never really used it. I never used this channel, but I started it intending to show people what I was doing with that. But like I say, I never really got a chance to use the channel properly. But this, I feel, is the appropriate way to use the channel right now. And after this, at 11 o'clock, you can come and watch me building this other website that I'm building right now. How are your mock grades used? I'm going to be completely honest with you, Amir. I don't know how your mock grades are going to be used. Right now, I'm not in the mainstream system, and I haven't been in the mainstream system since last year. And so I don't know how your mock grades are going to be used. Let me explain to you how it works. Normally, the way it works is, so normally with your GCSE grades, there's what's called a bell curve like this. And you have your kind of grade 9 students up here, grade 0 students down here. And what the government tries to do, Amir, is the government tries very, very hard to kind of keep it so that there's so the distribution of grades is all kind of there. So whatever grade you score in your GCSE exam, the government will, try to get a certain proportion of the students, at grade 4, 5, a certain proportion at 9, and a certain proportion down at the bottom, as few down here as possible. They'll probably want people on grade 1s. So I honestly don't know how they're going to do this. Obviously, your teachers are going to be consulted. In maths, there isn't coursework per se, so it's going to be 100% your teachers. For English, you don't have coursework now either. Stopped doing coursework a couple of years before I left mainstream school. So, yep, I don't know how that's going to work. In terms of, so it's basically just going to be based on what your teachers say. They may well give you some kind of assignment to do, but it's all still kind of up in the air, Amir. Anyway, so yeah, that's the situation. What we're going to do is, I think now, I'm going to wrap up now and start preparing for my, for me going over and building some more onto my website. Basically, I've been building this for my tutees to use primarily. One of my tutees is doing physics, and you can see the modules that I've been building. And basically, yeah, I've just been building stuff that is going to make it a little bit more palatable for them to be doing. And also, it takes a really, really long time for me to generate exam style questions. So it's really good to have the website to do it for me. Right, anyway, like I say, A-level GCSE Maths by Daniel Dallas. So I'm going to pop over and have a look at what you are doing, because I'm always interested to see what other people are about. I just want to make sure I contribute. I'm also aware that there are people who watch my YouTube channel, and I want to encourage them to be doing something rather than nothing. Something is definitely rather than nothing. But nevertheless, I'm a physics with maths BGC QTS qualified teacher who always got outstanding observations when that was a thing. Observe this, Ofsted, observe this! Anyway, thanks very much for watching. This is Mr. Jolt signing off. Clickety-click. Clickety-click the buttons here somewhere. Clickety-click, and I'll see you in a second at DevJolt. Yes,